Okay, welcome everybody. Hopefully this is working now. Let's see. I think it's up and going. Anyhow, tonight we're here in my dining room and we're going to talk about chromatography. But before we talk about chromatography, we're going to discuss one of my favorite things in the morning is a cup of coffee. This is my second take at this. I lost audio the first time, but I'm sure you've seen these before. This is a coffee filter. And so what I'm going to do is I'm going to use the material of the coffee filter to illustrate the concepts behind chromatography. All right, if I take a coffee filter and I tear a piece off of it and I have a cup of water and I'm going to do something really stupid and hold it over my computer, okay, if I take this coffee filter and I put it in the water, okay, probably not too surprised to see that if I touch it, the tip to the water level rises up the paper, okay? It keeps going and going and going. Okay, it's called a capillary action or a capillary action, and it moves the water up the paper. And we're going to use this concept to separate out mixtures in a process known as chromatography, right? This morning I made a cup of coffee, and you can see I took the filter out of the pot, and hopefully if I lift it up here, again, I don't want to drip coffee on my computer, but I'm hoping it's bright enough in here that you can see here's my original coffee grinds, and then there's a lighter spot, and then along the edge there's a dark spot again. And so what's happened is part of the coffee has separated from the original sample and moved up with the water. We'll come back to that though. Let's look at what's going on before we talk about the actual applications and real life examples. Alright, a couple of things we need to remember from last year. Solvents and solutes and solubility. Okay, those are three terms that I need you to remember. A solvent is a substance that does the dissolving. Like water is often referred to as the universal solvent because it dissolves a lot of things. Solute is something that is dissolved. All right. For example, when I have a cup of coffee on the weekends in the morning, my daughter sometimes, or my wife actually has a cup of tea, but I'm going to use my daughter as an example because Allie will take a bunch of sugar and put it in and stir it up. That sugar is a solute. All right, but Allie's example fits nicely with this last thing, which is solubility. Solubility is a measurement of how much can be dissolved. Okay, it's often measured in grams per liter. And in the case of Allie, she puts so much sugar in it that at the end I look and there's a ton of sugar. There's a centimeter of sugar sitting in the bottom of her cup. It's because the amount of sugar she put in, the amount of solute she put in, exceeded the solubility. So there's some of it didn't dissolve and just sat on the bottom of the cup. A couple other terms that, again, I'm really hoping you remember. Polarity and polar molecules. What am I going to use? I'll use this. Imagine this is a molecule. Okay. Polar molecules, well, all molecules have ends to them, and in the case of a polar molecule, you have one end that pulls the electrons harder than the other. Okay, and so what happens is the electrons get pulled more towards one side than to the other side, and so you get a negative end, and you get a slightly negative end and a slightly positive end. That's what's known as a polar molecule, and water is a polar molecule because the oxygen has a stronger pull on electrons than the hydrogens do. So you get a slightly negative end at the oxygen and a slightly positive end at the hydrogen. Last but not least, like dissolves like is a very simple term that involves polarity and solubility, and the concept that polar molecules are often attracted to other polar molecules because of the positives and negatives. So something like water will be attracted to polar molecules and dissolve them easier than something non-polar like vegetable oil, for example, doesn't dissolve in water. And because vegetable oil the molecules are great big long chains that are not polar. All right? Let's take those concepts and apply it to paper chromatography. Alright, here's a little diagram that shows the phases. There's two phases in paper chromatography, and I'm going to go back to my water sample here that I put in. Okay, there's a stationary phase, which is the paper. The paper is a solid, and so the atoms and the molecules that make up the paper don't move, hence they're stationary. Okay, the water is a solvent, and so when I touch the water or touch the paper to the solvent, the water or solvent moves up the paper. Okay, that's known as the mobile phase because it's mobile, it's in motion. Okay, remember we talked about like dissolves like, and so if I have a solvent like water and I put it underneath my stationary phase, if I have a mixture, okay, like we're going to use what are we using? I think a spinach extract, or you could even use markers, and you put your sample above the solvent. Okay, what happens is the water, as it moves up, it will separate out different parts of the mixture. Let me show you how that happens. Okay, so it says you put the corner piece of the paper of the stationary phase touches the water, and as we said, the water slowly begins to move up the paper, and here are two pictures that show that. Here's a photograph, and you can see we've put the paper in the water, and above the water level there's an ink spot. This is my sample, and as you can see, that water level is going up and it's getting closer and closer to the sample. Alright, moving along. Now let's see what happens. As the water moves past the sample, okay, some of the parts of the mixture begin to dissolve. Some of the solutes in the mixture begin to dissolve, and they dissolve at different rates. Okay, if we look at these two diagrams, here's my original sample down here. I have a yellow component, a pink component, and a blue component. And here's where the water is. You can see that the water level, the blue component has stayed right close to it. Okay, that means that the blue component dissolves really well in water, and so as the water moves, the blue moves with it. Okay, the yellow doesn't dissolve as well with the water, and so as the water moves past, the yellow is not affected as much. It doesn't move as much. It has more of an attraction, I guess, to the stationary phase, and so it stays closer to the original sample. Okay, let's keep it going. So as we said, solutes that are more soluble move farther up the paper. Solutes that are less soluble, hence the like dissolves like, move less. And so we get our components, our blue and pink and yellow, have now been separated by a process known as chromatography. Alright, take a look at this one. Which one do you think is the least soluble? Okay, well, here's my original sample down here. Here's my solvent level up here. Alright, this is where the water finished. And as you can see, the yellow didn't move as much as any other component, and so therefore is the least soluble in the water. It is more attracted to the stationary phase than to the mobile phase. So to take this back and look at my coffee filter from this morning, okay, I put the grinds in the filter, and there you go. I put the grinds in the filter, and I added water, or the coffee pot added the water. So the water drips down, and it gets the filter paper wet, and it gets the coffee wet. As the filter paper gets wet, the water moves up the paper, okay, and moves along past the sample. And you can see some of the sample stayed where it was. But as the water moves up towards the edge of the filter paper, some of the sample moved up with it. It's been separated from the original amount. Okay, this component is separated from this component. It's because this was more soluble in water and therefore moved with the mobile phase better than this did, which stayed with the stationary phase. Okay, so you just have basically competing forces, a mobile force and a stationary force, and depending on which the solute is more attracted to, it stays or moves accordingly. Hope that helps a little bit. I'm tempted to go make myself a coffee, and we'll see you guys on Thursday. Have a great night.